Okay, example 3 says give a possible positive angle measure and a possible negative angle measure for a 25-degree angle in quadrant 2. Okay, so they want the theta value, but they want a positive angle, which means we're measuring counterclockwise to that angle. They want a negative, which means we're going counterclockwise to that angle. All right, so we'll do the positive first. So 0, 90, 180, 270, 360. So always start off when you're doing these problems, put an XY axis there and put your angle measures in the XY axis. It tells us the reference, or the 25-degree angle, reference angle happens in quadrant 2. So our terminal side, they're telling us, is in quadrant 2. So I'm going to draw my vector into quadrant 2. My initial side's always the positive x-axis. There's my angle. If I'm trying to find the positive angle happens from here around to there. There's my angle I'll call theta. That's what I'm looking for. Reference angle always goes from the terminal side to the x-axis. So here the terminal side is here, the x-axis is there. This is my reference angle, that's 25 degrees. It's the exact same picture we just saw a moment ago. Instead of giving us the actual angle measure, though, they told us where it lived, quadrant 2. They told us what the reference angle is this time. So, theta plus 25 degrees equals 180. That's the relationship between the two angles in the picture. They make a straight line, so they add up to 180. We slide the 25 over and subtract, we get theta is equal to 155 degrees. That's the possible positive angle measure. Okay. Now if we want to find the possible negative angle measure, the negative angle is being measured from here clockwise around there. This is 0 degrees, this is negative 90 degrees, this is negative 180 degrees, this is negative 270 degrees, this is negative 360 degrees. If we go in the negative direction, we're going clockwise, that's a negative direction. Notice we're going 90 plus 90 plus 25. Right? We're going 180 plus 25. So, in the negative direction, theta is going to be negative 180 degrees minus 25 degrees, which is negative 205 degrees. Again, we're going in a negative direction, so negative 90, minus 90 more, minus 25 more. As long as we're going in a negative direction, we're subtracting numbers, minus, minus, minus. We get a whole bunch of minuses in conjunction. We're going to actually add the absolute values of those numbers to get a negative answer. The other way of finding the negative angle, probably simpler. Subtract 360 from that, plus 360 minus 155. 205, and then change the sign. All right, or just subtract 360 from that. 155 minus 360 is negative 205. Okay. Now, it said a possible positive, a possible negative. Those are both the right answers. You can have any, there's millions of right answers to this problem. If you keep on going around this circle, you keep on adding 90 degrees. So, if I'm at 360 and I keep going this way, now I'm at 450. Now I'm at 540, 630, 720, 810, 900, 990, 1080, and so on. Just keep on adding 360, you keep on getting around the circle. So if that's a right answer, and I add 360 to it, that'd be 515 degrees. That's also a right answer. Okay. For me personally, I usually go with the one between 0 and 360, but just know there's multiple answers. If it says a possible positive, any number or 360 plus that number is going to be correct. 360 minus the number is also correct. So again, if you get this answer, subtract 360, that gets you the negative. If you add 360, you get more positive. Subtract 360 from that, negative 565 is also right. negative 925 also, right? So on and so forth. So multiple answers possible. Main idea of today's lesson was standard position. Initial side's the positive x. We go counterclockwise in a positive direction to get to the terminal side. Reference angle lives from the terminal side to the x-axis. Second quadrant you go down, third quadrant you go up, fourth quadrant you go up, first quadrant you go down to get the reference angle. Always go from the side, the slanty side, to the x-axis.